Today our focus is going to be on finding segment lengths. So in the past we've talked about how to find angle measures. The only side length we've ever found was when we had this image here. And if you recall, ray BA and ray BC are both tangent to circle Q. So what can we say about BA and BC? If you remember, we can say that they are congruent. So we can say BA is congruent to BC. And that's how we would have solved for x. But what happens if we have two chords? So here we have an image, we have two chords that are intersecting. Okay, we have chord AB and we have chord CD, and they intersect at point E. E is not the center of the circle, but it's just where they intersect, and it cuts that chord into two parts. In order to find a missing length, okay, let's say we're looking for CE, we have to do this thing called part times part. So what that means is on chord AE, we'll look at, or AB, sorry, we'll look at this one first. We have to take one part of that segment, AE, and multiply it to the other part of the segment, EB. Now that's just one chord, so we also have to look at the other chord. So here we're going to look at CD, and let's do the same thing. We're going to multiply one part of the chord CE to the other part of the chord ED. So this is part times part equals part of the other chord times part. So what I'm going to do first is just give you equations, then we're going to talk about actually how to use them, and it does get a little easier once we put numbers to it. The second one we're going to look at is secant, secant. So our two lines intersect the circle twice. So we have a BE and CDE. For secant, secant, you take the measure of the whole, so AE, so however long that is, you would add the two pieces together, times the outside piece BE. And you would set that equal to the whole, of the second secant CE times the outside piece of that secant DE. So this one would be whole times the outside equals whole of your second secant times the outside piece. The last power theorem we're going to look at is secant tangent. Secant tangent is where you have one segment that intersects the circle at two places and one segment that just has that one point of tangency. So again, we have A, B, C, and our point of tangency is D. So AC is a secant. So again, just like before, we're going to take the measure of the whole, AC, and multiply it by the outside piece, BC. But because we don't have a whole and we just really have that outside piece, we're going to take the tangent and square it. So this one would be whole times outside equals tangent squared. So let's actually put numbers to this, and that's where it's going to start making some sense. So the first two problems we have are chord, chord. So we have one chord here, A, B, and we have another chord, D, C. So let's start with the green one first. You have two pieces, AE and EB. So 6 times 5. Part 1 times part 2 of the same chord. Your second chord, the blue chord, you have two pieces again. You have 8 and you have X. So when you multiply those together, you're going to get 30 equals 8X. When you divide by 8, we're going to get 3.75. If you look at the second one, again, we have our two chords. Okay, So if we look at the green chord first, you have two pieces. Piece 1 is 9, part 2 is 4x. So we would say 9 times 4x, and that is equal to the blue chord, which since we have more than one number on GN, let's put it in parentheses. So we have 4x plus 2 in parentheses times your second part, which is 8. So for this problem, 9 times 4x is 36x. And then when you distribute the 8, you're going to get 32x plus 16. So we have to get our x's together. So we would say 32 minus 32x. And we would be left with 4x equals 16. And then when you divide by 4, this problem, x is 4. So that's chord. If we have secant, what we have to do is first find the whole of our top secant. And remember, you just add those two pieces together. So this would be x plus 13. Okay, and because it is more than one term, we have to put it in parentheses, x plus 13. And then we multiply it by the outside piece of that same secant. So it's times 13. We set this equal to the second secant, so the bottom one, and 30 plus 9 is 39. So that's our whole times the outside piece of that secant, which would have a value of 9. So if we distribute the 13, we're going to get 13x plus 169, and that's going to equal 351. After all said and done, and you divide it by 13, x is going to give you 14. For problem number 4, again, we take our whole value, which you add the two pieces together, which is 6. So you have your whole times your outside piece, which is 4, equals our whole, okay, which is 2x plus 8. Okay, so you just add your like terms together. So we would have 2x plus 8 times your outside piece, which is 3. When you simplify, you have 24 is equal to, and we distribute the 3, 6x plus 24. Get our constant number to the one side. 24 minus 24 is 0. 0 is a real number, so we can continue to go. So we have x is equal to 0. Don't forget about that 0. A lot of people freak out and they're like, oh my gosh, can't have a 0. That's not cool. But it's allowed, I promise. For number 5 and 6, we have secant, tangent. Okay, secant, tangent, remember, is the whole, just like we did before. So, okay, so we have a whole, which is 7 plus x, times that outside piece is equal to your tangent squared. So here it is very important for you to know the difference between secant and tangent. Which one crosses the circle twice and which one just touches the outside. Okay, because then it's going to help you figure out how to set up this problem. So we would distribute the 7. So we have 49 plus 7x is equal to 100. And we did subtract your 49 here. We got 7x is equal to 51. And to the nearest decimal, we have x equals 7.3. In problem number 6, our whole is x plus 4, because remember you add the pieces, times the outside piece of 4. That's equal to your tangent squared. So again, you distribute, you have 4x plus 16 is equal to 36. When you subtract 16 to both sides, you have 4x is equal to 20, and x is equal to 5. So that is each of the 3 equations that we talked about on the first page. Hopefully with numbers it was a lot easier. I have 3 more problems. I'm going to make it a little bit more difficult because we may throw in an x squared here or there, but just, hang on there with me. 3 more problems and then we're done. So here we have secant, secant. Notice it touches the circle twice. Our whole on the top is, they're like terms. 6x plus 8x is 14x, and our whole on the bottom is 16. So our equation would be 14x times 8x is equal to 16 times 7. So 14x times 8x is 112x squared, and 16 times 7 is 112. Move our 112 to the other side, and that goes into 112 all of one time. So remember, to get rid of a square, you have to square root, so x is 1. So I made it a little bit more difficult, but kept it a little easy. Here we have chords, so remember we have two chords we have to look at. And we multiply the two numbers that are on that chord, so 4 times x and 5 times 8, which is the blue chord. 5 times 8 is 40, and when we divide by 4, x is 10. Last but not least, we have another secant tangent. So here our whole is 5 plus x, and our outside piece is x, and that's equal to 6 squared. So when we distribute, we have 5x plus x squared is equal to 36. Now the difference between this problem and the one up top is we have this 5x. Because we have a b term in your quadratic, we have to factor. So let's bring 36 to the other side. And you have x squared plus 5x minus 36 equals 0. So we have to figure out what multiplies to negative 36, adds to 5. If you said negative 4 and 9, you are correct. Once you apply zero product property to this, you're going to get x is 4 and x equals negative 9. We can't have that negative because it's going to give us a negative distance here, and we can't have that. So x is 4. The homework in your packet are numbers 67 through 79. Give those a try for tomorrow. Good luck. If you need questions, please email and ask.